Okay, let's say the heights of 1,000 girls is found to be normal, a normal distribution, with a mean of 64 inches and standard deviation 2 inches. Number one. Number one. About what percentage by the empirical rule are between 62 and 70 inches, 68 inches, sorry. About what percentage are between 62 and 68 inches? All right, so I've changed it up. I've got different mean, different standard deviations, so let's draw the picture here. Because I'm using the empirical rule, well, what goes in the middle? Which number goes in the middle? The mean? 64. 64 is right in the middle. Well, 62, first note is 62 is below the mean, so I'm going to put 62 over here. Right? 62 goes over on the left. But since I'm using the empirical rule, let's think about it a little more. I put 62 over here, and how many standard deviations do I go to get there? Well, I'll just go one, don't I? One standard deviation, because one standard deviation puts me 2 units down, so that would put me at 62. So 62 is one standard deviation below. Okay? What about the 68? Let's go ahead and draw the picture here. 68 is how many? Well, 68's over on this side, but to get to 68, I would go to 66 and then to 68. So I'd go 2, right? 2 standard deviations above. Everybody okay with that? So I want this from here to here, but let me put that line down the middle because I'm going to have to split this up, aren't I? Because one standard deviation below, I'm dealing with the one standard deviation, which, what's the percentage from the empirical rule for one standard deviation? 68%. So I'm going to use here the 68%. 2 standard deviations, that's the second one, that's 95%. So I'm going to use the 95% here. So that's what I'm saying. I'm going to split it up right down the middle. Okay? Now do you see what I need to do? Well, to find out this much, 68 is from one below to one above. I only want one below, don't I? So what am I going to have to do with the 68? Half it. So I'm going to take half of the 68, and that percentage will be this percentage here, which that would be 34. I'm going to have to do the same thing with the 95, aren't I? 95% are within 2 standard deviations of the mean. I only want 2 above the mean, though, for this percentage. So I want half of the 95, which is 47.5 again. Question or concern? See what I'm doing there? Figuring out how many standard deviations each is, which percentage goes with it, and then usually just half. You're just halving it because it's mix and match there. Okay? Now, what's the final answer though? Well, I've got 34% here. I've got 47.5 here. Final answer would be those added together, right? 34 plus 47.5. 81.5%. Okay. All right, let me give you another one here, number 2. About what percent are between number 2, they're going to be between, let's do 68 and 70. What did I say? 66 and 70. What percentage are between 66 inches and 70 inches? Okay, picture. What does the picture look like? Well, you've got 64s in the middle. What's different about this one, though? Where is the 66 and where's the 70? Both of them are over on the right of 64. That's different than what we've encountered yet. I've got 66 over here, and I've got 70 also over here. Now, how many standard deviations am I talking about for each? Well, for 66, I go 1. So 66 is 1 standard deviation above. 70 is, well, I need to go 68, 70, right? Because each standard deviation is 2. So I need to go 3, right? 1, 2, 3. It's 2 away from the 66, but we're judging it from the mean. So 70 is 1, 2, 3 from the mean. 3 standard deviations from the mean. Okay, you with me? All right, so what's the, I'm looking for this, so I'm looking for between 60, so I'm looking for this. All right, so let's think about it. 1 standard deviation, so for the 66, I'm going to use the, which percentage? It's 68, 95, and 99.7. That's the 68, yeah. 1 standard deviation, I'm going to use the 68%. 3, that's the third one. That's 99.7%. All right? Okay? But I have a bit of a problem. Okay? Let's just kind of work our way through it. I'm only dealing with the above, 1 standard deviation above, so am I not going to have to take half of 68? Half of 68. Now, that's 34. Let's do that over here. If I were going to put that percentage on my graph here, where would that go? Wouldn't that be between the mean and 66? That's 34% right in there, which is not anything really I need to know. I need to know right here, but we'll get to that. All right. Now, 3 standard deviation above, so I need to take half of the 99.7 because 99.7 is from below to above. I only want to go the above, so I need to do the half of 99.7, which is 49.85. Now, what part of the graph does that represent? That represents between, this is the percent between the mean and 70. which it's kind of hard to label here, but that's from here all the way to there. That's 49.85. Do you see how I'm going to get this piece? So neither of those pieces is what I need. This is 34%. This whole chunk here is 49.85. Do you see how I'm going to get that? Subtract. I'm going to subtract those two. I'm going to subtract to get this amount right here. I'm going to do 49.85 minus 34. That's going to give me my answer to my question. That's 1585. Now, here's a general rule of thumb. I can just use the two I have here. Here I subtracted. Here I added. What's the difference? The difference was I added when I had one value below the mean, one value above the mean. I subtracted here when what happened? When they're on the same side of the mean. And it doesn't matter, it worked the same if they were both on the lower side of the mean. If they're on the same side of the mean, the general rule of thumb is if they're on the same side of the mean, you subtract them. If you put them on the graph and on the same side, you subtract the percentages. If they're on opposite sides of the mean, you're going to add the percentages. Okay, so that's your general rule of thumb. And we'll encounter more of that in a second. Okay? But let's do one more. Number 3. About what percentage are more than 66 inches? About what percentage are more than 66 inches? Well, let's draw the picture. $64 in the middle. 66 above that. How many standard deviations above? 1. Okay, so 1 standard deviation above. We just did that one, didn't we? 1 standard deviation above. So that's the 68%. I'm going to use 68%. All right. There's my mean. There's my 66. But which part here of the graph am I wanting the percentage of? I want the percentage more than 66. So I'm wanting this little piece out here. Now, let's talk about the 68. Of course, I'm only doing above, so I need to take half of the 68, which is 34 again. But is that this percentage out here? No. The half of the 68 is in here. It's between the mean and the value. That's 34% right there. How do I get this piece? Well, that's where, again, we're going to utilize, one way we do it is utilize the fact that this graph is symmetrical. And from 64 on out, how many percent do I have? Well, 64 being the mean, the 64 splits it in half, doesn't it? So there's 60, above the 64, there's 50%. In other words, from 64 on out, there's 50%. So if that's 50%, this is 34%, then what is this? Isn't it 50 minus 34%? See that? See what I did there? I know this is 34, so this has to be 50 minus 34. Because from 64 all the way out is 50%. This is 34%, so this has to be 50 minus 30, which is 16%. Let me do one more of those. About what percent are more than 60 inches? About what percentage are more than 60 inches? Well, 64 is here, and then 60 is back here. So it's 62 and then 60. So that's 2 standard deviations. So I want this. Put a little mark there. This. That's what I want. So 60 is 2 standard deviations. That is what percentage? We got 68, 95, 99. It's the second one, right? 95%. So I'm going to use the 95% here. However, I'm not going to use exactly all of the 95%. What that gives me, since I'm only going from one side for the 60 there, I don't have anything on the other side, but as far as numbers, I'm going to have that. So I'm going to do half of 95, and let's think about what that is. 47.5 is the number it is. But what does that represent on the graph? Doesn't that represent on the graph this piece right here, from 60 to 64? That's 47.5. I've got this other chunk out here. What is this other chunk? Well, the other chunk is from 64 on out. Isn't 64 the mean? And what do I know about the mean? Doesn't it split the graph in half? So wouldn't out here be 50%? So I've got 50% out here. So I've got 47.5 here, 50 here. So what's the total altogether? Add them together. $97.5. All right. Now, here's a little point. Notice here, the key words here were more than, and this one also had more than, but you can have some less thans. Anytime you have more than or less than, that's the phrase used. Big hint there. If you have more than or less than in the wording of your problem, that tells you you're going to use, somehow or another, you're going to use 50%. Use the 50% number. You're either going to, because notice here, on this one I subtracted from 50%. This one I added to 50%. So that's what I'm saying. If it says more than or less than, more than we could either subtract from or add to 50%. Same thing with less than. Works the same way for less. But if it has those words in it, you're going to somehow use your 50%. You're either going to add to 50% or subtract from. Just depends on the picture. That's why the picture is helpful here. Okay? All right. One other point here. Number 5. How many girls are more than 60 inches tall? How many girls are more than 60 inches tall? Remember our original problem. The heights of 1,000 girls are this normal distribution. We found that 97.5% of them are greater than 60 inches tall. So how many of them then would be more than 60 inches tall? Wouldn't I just take the 97.5% times it by 1,000? Which is 0.975 times 1,000, which is 975. Yeah. If it asks you, instead of percentage, if it asks you how many, you just take your percentage and multiply it by the number that you have. I think in the book it might have 10,000. So just whatever your percentage is, multiply it by how many there are. In this case, there was 1,000. So if it asks that angle of it. So you're still going to do the same thing, just multiply it by how many there are.